Good afternoon, everybody, and welcome to the first of a series of 4 webinars hosted between Chartered Institution of Water and Environmental Management and the British Hydrological Society. So this series of webinars is about climate science in water systems to inform adaptation and resilience to climate change. And it's part of that wider series of events that we are running. And it is hosted by the CIWEM presidential team and the president of the British Hydrological Society. So I'll just run through some housekeeping and then do a bit of an introduction. And just to note that this event will be recorded. Okay. So I'm not sure why that's not moving on to the next slide. Has it moved on for anybody else? There we go.
It has now, yeah.
Yeah, it's a failure of the operation of my computer mouse. So it's a bit of general housekeeping. So the recordings will be available on CIWEM's YouTube website at a later date. It's a really good website to go and check out in terms of CIWEM's YouTube channel for past webinars, if you haven't already found that. If you experience any technical issues and you need any assistance, please raise your hand and use the chat feature on Zoom. And Barbara from CIWEM HQ is on hand to help you with those. We do have a Q&A session at the end of the presentation. So if you want to ask a question, please use that Q&A facility on Zoom and keep the chat for any technical issues with the webinar. And when asking your question, I mean, it may be that you want to direct it to all of the speakers. If you want to direct it to a particular speaker, please state who you are posing the question to. And this event counts for an hour of CPD. We don't provide CPD certificates, however, but all counts towards your wider learning and development. Okay. So we'll do some introductions. So for people I haven't met before, my name is Hannah Burgess and I am the president of CIWEM. It's a real privilege to hold the presidential role because I've volunteered for CIWEM for 20 years now, alongside my day job in the flood and coastal sector. And I bring to the presidential role that experience of chairing CIWEM's Rivers and Coastal Group and CIWEM's West Midlands branch. And in terms of my interest in this webinar series, my experience, flood risk assessments, flood mapping and modelling, flood schemes, and also getting involved in coastal change adaptation projects. So Duncan, do you want to briefly introduce yourself and then I'll talk about CIWEM?
Yes, hi everyone, I'm Duncan Faulkner, President of British Hydrological Society, and I'll say a bit more about BHS in a couple of minutes.
Thank you. Okay, so about CIWEM. So for those of you that are not aware of who we are a Royal Chartered institution, which means that we can award our own chartership, which is Chartered Water and Environmental Manager. We also have a license to provide further charterships, including Chartered Engineer, Chartered Environmentalist and Chartered Scientist. We have over 11,500 members in 89 different countries, and about 8,000 of those are based in the UK. If you want to know more about CIWEM, do have a look at our website, where you can find our corporate strategy, more about CIWEM membership, and more about CIWEM policy as well. And in terms of the presidential team for this year, so the presidential team for this year consists of myself and Peter Rook, who is our early careers president, who will introduce himself a bit later on when he chairs the Q&A. Our theme for this year is about the ripple effect and about scaling up resilience and adapting at pace to climate change. And it really is that, facilitating and supporting professionals to act at pace. So, when I look back over 20 odd years of my career, I can see that we've made slow progress over time, from starting to take climate change into account and to getting increased guidance over time. Obviously, the climate science changes, but now we are in a phase of what CIWEM has declared as a climate and ecological emergency, and there's a real need to scale up what we are doing. Our presidential theme has several sub-themes. You can find out more about this. There is a web page that we have as presidents with a short video on. But our sub-themes include recognising the central role of local communities for place-based adaptation, that move from managing risk to resilient places, managing our water sustainably, looking across the whole water cycle, which very much underpins actually the different topics that this series of webinars will cover. CPD is an enabler to share best practice and equip our professionals. And over the presidential year, we are also looking at career resilience, as well as we might think about as resilience to climate change, and harnessing new technologies such as artificial intelligence. One of the things that's really important, and why we've come together with the BHS for this webinar series, is that in order to make informed decisions on how we adapt at pace, how we can support communities, the environment and the economy to become more resilient to climate change, we need to base that on the latest scientific evidence. And it's that where this series of webinars is coming in particular, which is why it's called around climate science. Okay, so this is the first of a series of 4. So today we'll be looking at an overview of the latest climate science, including the likelihood of more extreme hydrological events. Next Wednesday, we'll be looking at flooding and in particular rainfall intensity, peak river flow and volume, and sea level rise. The following Wednesday, we'll be looking at water resources and groundwater, including low flows and considering drought and the impacts on groundwater. And then on the 26th of February, we'll be looking at water quality and the impacts of our changing climate on physical, chemical and biological quality in freshwater environments. So I'll just hand over to Duncan at this point to give a bit of an introduction to the British Hydrological Society.
Thanks, Hannah. I've been involved with CIWEM and BHS for pretty well the whole of my career, so it's great to be doing this joint event. BHS, if you're not familiar with it, is all about bringing people together with an interest in hydrology to learn from each other, to support each other. Our mission, our goal is to advance education, research and practice in the field of hydrology. And really what we want is for hydrologists to feel valued and for everyone to feel good and interested about hydrology. We're fairly unique in the mixture of backgrounds that we come from. So we bring together people from research, academic type backgrounds with lots of practitioners, consultants, regulators, and also people from the third sector, asset owners like water companies and so on. So there's a lot of different perspectives that we bring together. Next slide, please, Hannah. So you can see here a list of the activities that we do. We run lots of events like this, and I'll have a list at the end of some forthcoming ones. We try to promote hydrology as a career. So for instance, we offer studentships to support master's students. We offer an undergraduate dissertation prize. We also eat a lot of cake. So here we've got a photo of me cutting our 40th anniversary cake from a couple of years ago. We publish a newsletter, Circulation, and we try to have lots of active links with other bodies, not just with CIWEM, but international and national bodies as well that relate to hydrology. Next slide, please. So we get together, not just beside rivers like in the first photo, but also in rather grander societies. This is a photo from our symposium last September, which is at Oxford University for our dinner here. And membership of BHS isn't just for people who call themselves hydrologists or who are qualified in some area of hydrology. It's really for anyone whose work or interests touch on parts of the water cycle. So we welcome everyone. BHS membership is extremely good value, and in particular, if you're at the start of your career, we offer free membership to undergraduates and apprentices and very low cost membership to people in the first 5 years of their career, just £15 a year. And for your membership, you get BHS magazine, you get reduced fees for BHS events, access to travel grants. But there are much less tangible benefits as well in terms of sort of feeling part of a sort of supportive network, plus all the cake, of course. Next slide, please. So if you want to join BHS, have a look at our website, hydrology.org.uk, and you can see the link on the bottom right there for how to join. Right, that's handing over to you now again, please, Hannah.
Yes, thank you very much, Duncan. And I'm looking forward to enjoying some VHS cake at some stage. And I think maybe we have to take that on board as CIWEM as well. More cake, please. Okay, so I'm now going to introduce the first of our speakers. So I'm going to stop sharing my screen to allow Chris to share his. And I'm going to introduce Chris while he brings up his presentation. So Chris is the climate science lead at the Climate Change Committee. He is a senior analyst at the Climate Change Committee, currently working on the 4th UK Climate Change Risk Assessment, CCRA 4. Chris is an experienced hydrologist who specialises in climate change hazards and impacts. He has 15 years experience working on climate risk and resilience assessments, flood alleviation schemes and flood risk assessments. And he has extensive knowledge of climate science, climate projections and associated impacts. So over to you, Chris. Thank you.
Thanks very much, Hannah, and thanks for inviting me for this webinar series. So I'm going to talk you through the 4th independent assessment of UK climate risk. So we're in the process of delivering the 4th assessment. So I'm just going to give you an overview and provide some policy context for this webinar series. So in terms of what I'd like to cover today, so I want to talk about the adaptation policy cycle and how that relates to the climate change risk assessment and other policy actions. I'm going to talk about the 4th risk assessment itself, what we're looking to do to evolve it for the next iteration. I'm going to talk particularly about 2 of our products that we're delivering, so the technical report, which some of you may be familiar with from previous assessments, and our new well-adapted UK report. And then finally, I'll provide some opportunities to kind of feed into this process. So in terms of the adaptation policy cycle, this happens over a 5-yearly period. So the Climate Change Committee will deliver an independent assessment of climate risk, which then feeds into the government's own assessment. So this happens, the previous one was delivered, our assessment was delivered in 2021. There'll be the government's assessment was laid before Parliament in 2022. And then for the new cycle, for the late cycle, we're aiming to deliver our report in 2026, so next year, for the government to provide theirs in 2027. So, I mean, there's a lot that then goes into that. So if we're talking the latest UK climate projections will feed into the process. We'll be looking at the latest research and science on climate impacts and adaptation. We also have adaptation reporting powers, which are a requirement for a number of organisations. Well, they're not actually mandatory, but a number of organisations will deliver these adaptation reporting powers reports, which will outline their own adaptation planning. Now, these were out of sync with the previous CCRA 3, so that adaptation reporting powers 3rd round was delivered after CCRA 3 independent assessment. For this round, we have the 4th ARPs. They should have been, in fact, delivered just recently. So those will be feeding in. And then we have wider regional and sectoral plans and other grey literature. So a lot of the evidence that we draw from is not just academic. It's a lot of it comes from grey literature, local authority assessments, and other work by other organisations. And then also the wider government policies. And then this all feeds into the national adaptation planning cycle as well. So the risk assessment is the first step, then the national adaptation plan, which was the last one was delivered in 2023. And then from that, we will do our own assessment. The CCC will do our own assessment of progress towards those plans, and also the plans themselves, whether they're sufficient. And then we also produce, as part of the risk assessment, we produce a statutory advice report. So this is our own advice on what we think the policy should be to tackle climate risk. So that's the context for the adaptation cycle. In terms of the latest risk assessment, so we're seeking to update the CCRA3 assessment to basically ensure that continuity. This is an iterative process that happens over that 5-yearly cycle, and we need to kind of build on previous assessments and evolve those as the science evolves, as the evidence base evolves. So we aim to provide an authoritative evidence base to draw from that's up to date. So we'll be looking predominantly at that evidence from the last 5 years since CCRA3. And we're aiming, because our progress reports have told us that we're not currently adapting to present day climate. So we need to be doing more to tackle climate risk across the UK society. So we're really looking at that action in the next 5 or 10 years, what government needs to do in terms of what policy it needs to put in place to enable this change. And the other thing we want to do is to ensure that the latest report is as accessible as possible for a range of users. But our kind of key target is those senior decision makers in government, and also the working level policy makers. But we're aware that the reports are also widely used, so we want to make them as accessible to everyone as possible. And if you've read CCRA3, you'll know that it's not the easiest document to read. So we're trying to address that, and that's one of the key aims for this cycle. So in terms of our main outputs, again, we'll be delivering a technical report, which will be an update of the CCRA3. So this is looking at the risks to the UK and how urgent it is to manage those particular risks. So it's identifying all those risks and then what we need to manage them. So if we had an exam question for that, it would be, what are the risks that need to be managed? Now, a new product that we'll be delivering this CCRA for CCRA4 is the Well Adapted UK report. So this is a new report that aims to set out a vision of what a well adapted UK would look like, but with specific actions that need to be put in place and evidence to support those actions. So there's much more focus on what will the costs be of not acting on adaptation, and if we do act, how much will those adaptation options or packages cost? So this is outlining what actions are needed to manage the risks that have been identified. And then we also have our statutory advice report, where we can be more, it's less evidence focused and more about what policies need to be put in place to enable the action that we're outlining. So this is the committee has a bit more free reign on what we can put in there. So in terms of the specific outputs, so the technical report is currently being delivered by a consortium led by the Met Office. So as I was saying, we're looking to update this from CCRA3, refine the urgency scoring process, so how we identify those risks that are most urgent, but also consider how we reduce the number of risks, because DEFRA, who commissioned this work, have told us that the number of risks that were identified as urgent action needed, we had 61 risks that were identified, and the number of those was about half of those risks were the most urgent action needed. So we're looking to refine the process to identify those actions that are really urgent, but also potentially bring the number of risks down as well by reviewing or refining that risk identification process. And again, we're looking to co-develop these outputs to make them much more accessible to lay. So written in plain English, and not too focused on scientific language. sort of much simpler English. So in terms of the technical report progress, we've now identified those risks and agreed those with the committee. So this is showing the preliminary risk magnitude scores for England in the 2050s. So this is, as I say, this is preliminary. So these are initial kind of results. So we've split our risks across what we call 4 outcome areas. So that's the built environment and communities, economy, health, infrastructure, and land, nature, and food. So these are we've reviewed those original risks from CCI3, consolidated some. The keen-eyed amongst you will notice there's no international risks in there now. So we had international risks. These are being integrated into the UK risks, but there is some international risks that are don't fit nicely within these risk buckets. So we've also, again, the keen-eyed amongst you will see there's, for the magnitude scoring, there is now a very high category. So this is to try and identify those risks that are really key, or ones that are the most urgent to address. So as I say, this is preliminary. That's why you see there's some economy risks that are in grey, which have not yet been scored. But yeah, that's kind of an overview of kind of where we're at with identifying those risks. So then the second product that we'll be producing is the new one, which is the new product for CCI4, which is the well-adapted UK report, which I was saying this will be outlining the actions, setting a vision or goals for the government, or targets for the government, and outlining what actions need to be taken, and then providing that hopefully much more robust evidence base to propose those actions and manage those risks. But they will include much more economic analysis in terms of what the costs are and what the benefits are of adaptation action. So in order to do this, we've got a number of cross-cutting or bespoke research projects. So some of these we're doing internally at the Climate Change Committee. So those top ones, these are kind of bespoke projects that are delivered internally. So that one on vulnerability, so considering how people's age or demographics or socioeconomics affects the risk, and how we can start to tackle that. We're doing a piece on cascading risks, looking at from a case study perspective. So thinking about how these risks can propagate through systems. So, and a good example of that is the 2015 floods in Lancaster, where the floods actually took out the energy systems and the communication networks, which made recovering from those impacts much more complicated, and caused much more impact itself from the event than just the flooding itself. We're also thinking about the policy interactions and co-benefits. So where there's quick wins, where policies might provide benefits to multiple sectors, not just the one that you're targeting, but also where policies might impact on other risks or other sectors negatively. We're also developing a new monitoring and evaluation framework, or an updated monitoring and evaluation framework, to ensure that the targets that we set can then be monitored through data and evidence, which is quite a challenge on adaptation, as you can appreciate, given the diffuse nature of how it's delivered. We're also using citizen panels to kind of provide information on what people want and how people think things should be paid for, in terms of things like thinking about flood defences, who should fund them, and who should be paying for them if people aren't directly benefiting themselves. And then also local authority adaptation, because as you all be aware, a lot of this adaptation will be delivered at the local scale, and local authorities are heavily involved with that delivery. Now, in terms of external research projects, we have what we refer to as these new deep dive projects. So we've set out a very detailed end-to-end risk assessment methodology that goes all the way from the hazards and risks themselves to through the adaptation packaging, costs of the risks, costs of the adaptation, to provide this basic example projects of how we think that the end-to-end risk process should be, assessment process and adaptation process should be done. But we only have limited resources, so we've had to narrow down the scope of what we will be looking at. But we've tried to incorporate projects across all our outcome areas. So, for instance, the infrastructure projects, the water scarcity, we're doing a project on water scarcity. Now, the public water supply has already quite a lot of studies done on it. But the sectors that aren't often included in that are energy, industry, and agriculture, which all have particular water needs. So we're looking at a water scarcity project on those particular sectors. And it's important to note that as we transition into a net zero society, those industries might change. So for instance, we might be much more reliant on hydrogen production or carbon capture and storage, which means that the water usage might change and the locations where that water is being used may also change. I think the Labour just announced a new AI area in I think in Oxford. So obviously data centres is another consideration for water scarcity. We're also very keen to look at extreme heat projects. So both across health and built environment, so health to the health and social care sector, but the built environment to the building sector. Because this again has been identified as a potential gap and also an urgent risk, because as we know from the 2022 heat wave, heat extremes are changing very rapidly and are one of the fastest changing hazards when it comes to climate and climate projections. We also did a small project on cold supply chains. So thinking about where we get our food, cold food and medical supplies from, and how temperature might affect the transport and storage of those. And then finally, a one on farm landscape, where we're looking at particular temperature and heavy rainfall, but with a focus on, I think, on dairy and cereal production. So that's kind of a sort of an overview of what we're doing on the Well Adapted UK report and what projects are feeding into that. So in terms of opportunities to get involved, we now have our second round call for evidence open, which is open until the 31st of March. This will be feeding into both the Well Adapted UK report and the technical report. And we're particularly interested in both academic literature and grey literature. I think grey literature on this, particularly for adaptation, has often been previously a bit undervalued. I think that a lot of the really good evidence out there comes from the grey literature. That's perhaps both organisation reports, local authority work. So there's a lot of really good stuff out there, and we just need to try and get hold of that. So if you know of any projects that could sort of fit that bill, then we'd be really keen to hear. And that's being run by the Met Office currently. So, but yeah, thank you very much, and thanks for listening. And hopefully that provides a good overview of the CIWEM report.
Yeah.
Thank you.
Thank you very much, Chris. So we're now going to hand over to Dr. Wilson Chan. So I will introduce Wilson as he shares his screen. So Wilson is a hydroclimatologist at the UK Centre for Ecology and Hydrology, UKCEH, within the Hydrological Status and Outlooks group. He is interested in the interface between climate science and hydrology and the impacts of climate change on hydrological extremes. He is also involved in the UK hydrological outlooks in operational river flow forecasting and in the National hydrological monitoring programme, which produces the monthly hydrological summary for the UK reports. Wilson completed his PhD at the Department of Meteorology at the University of Reading on present day and future risk of extreme hydrological droughts in the UK. Thank you, Wilson, and over to you.
Great, thanks so much, Hannah and Duncan, for the invitation. Can you all see my slides correctly in full screen?
I can see them, yes.
Great, thanks. As Hannah said, I'm based at the UK Centre for Ecology and Hydrology, and my research mostly focuses on climate variability and climate change and its impact on water-related extremes. Today, I will talk about the different approaches researchers have taken to translate climate outputs for hydrological applications. So why are we interested in this? I think this needs very little introduction. We've seen dramatic warming trends across Europe and the UK, with strong trends in maximum temperatures over the past few decades, for example. Recent hydrological extremes include the wettest winter half year on record in 2023-2024, and this followed on from the 2022 summer drought. So to try and understand what climate change means for hydrological extremes, we need approaches that can incorporate climate change information to project changes in hydrological variables. So the most common source of information is simulations from global climate models, and I'm sure many on the call will be familiar with this. Climate model simulates the global climate system and forms the basis for long-term climate change projections. These models divide up the Earth into a series of boxes or grid cells. The model then calculates the state of the climate system and the underlying physics to simulate processes such as heat and water transfer and biogeochemical cycles. And for processes that happen on scales that are smaller than a grid cell, these models uses parameterizations or simplifications of these processes. And this is a major source of uncertainty in climate projections, particularly relevant for projected changes at the regional scale. Climate model resolutions have increased substantially over the years, looking at successive generations of the UK's national climate model projections. We see a growth from only 6 model grid cells covering the UK in 1998 to convective permitting 2.2 kilometer resolution simulations in the latest UKCP 18. I think it's useful to recognize that the desire to understand what climate change means for UK hydrology is not a new challenge. So this was a review paper I published a couple of years ago, where we identified a growing interest in the academic literature since the 1990s, with an increasing number of papers over the years. And we also identified the changing nature of how researchers have tried to understand the impacts of climate change on UK river flows. And I think by looking back at how these approaches have changed and why these approaches have changed over time, we can identify research gaps and emerging approaches. So I only reviewed papers up until 2021 in the review article, but more recent work by colleagues at UKCEH and Bristol University for the Environment Agency provides an even more updated review of the historical developments of different modeling techniques specific for drought. So from all those papers since the 1990s, I classified each one of them based on the approach they took to project climate impacts on UK river flows. And I identified 4 broad categories. The first one was what we termed stylized approaches. So these were pioneering studies in the 1990s and early 2000s, and some of the first to assess potential changes of climate change to UK river flows. And these stylized approach mainly relied on expert judgment at the time, and mostly did not directly use climate model outputs. So the example shown on this slide were 3 stylized scenarios for summer rainfall changes at the time. And these stylized scenarios were often combined, such as combining a summer drying scenario with a strong increase in evaporation, for example. Climate modeling was still in their infancy, and hydrological models were not yet widely established at the time. So these stylized scenarios were not necessarily physically consistent, but these studies represented a major advancement in understanding the sensitivity of different catchments to climatic changes. Beginning in the early 2000s with the advent of climate models with higher resolutions, more and more studies started using climate model output more directly. But the methodology to apply climate model outputs to hydrological models differ between different studies. And generally, there are three approaches. The first is what's known as the change factor approach. So this is where change in temperature or rainfall from a global climate model is used to perturb historical observations. So the example shown here is observed temperature for a year with the projected change in temperature added on to the historical observations. So this approach is obviously very easy to apply, and it is widely used, but it retains historical variability. So there is a risk of downweighing the role of climate variability when using this approach. Second, researchers have used statistical downscaling techniques to downscale climate model output to the scale of our hydrological models. And the example here is a simple rainfall-based downscaling technique, which distributes the modeled rainfall according to observed rainfall patterns. Other more kind of complex statistical downscaling techniques uses other atmospheric covariates, for example. The downscaled climate model data is then used to directly drive hydrological models. So unlike the change factor approach, which retains historical variability, downscaled climate model data can provide transient projections over time, which explores a fuller range of climate variability. And third, the most computationally demanding approach is dynamical downscaling, which uses the boundary conditions of a DCM to drive regional climate models. So this was done for the UKCP18 regional projections, for example. However, given the computational demand involved, there tends to be a smaller number of ensemble members. But similar to the statistical downscaling, this approach has the advantage of providing transient hydrological projections over time. Studies have also adopted a probabilistic approach, particularly after UKCP09 and UKCP18. And statistical models are trained and emulate the behavior of these climate models and to generate an additional sample of outcomes. So the example on the left is an early study using UKCP18, and on the right, a later study comparing projected river flow changes between UKCP09 and UKCP18. And it shows that the uncertainty range has actually remained quite similar, and the direction of change for some of these catchments also remained uncertain. There is some caution needed when interpreting probabilistic projections. For example, they tend not to be spatially coherent. There are also underlying assumptions about the probabilities themselves. For example, there is a large uncertainty in how atmospheric circulation will respond to climate change. So projections for changes in storm tracks or the frequency of atmospheric blocking leading to wet or dry weather, they're very different between different climate models. So the probabilities will vary substantially as well. Many studies recently have used the latest UKCP18 projections, and one of the latest example of national river flow projections using UKCP18 is the E-flag projections at UKCEH. The 12 regional climate model simulations were used to drive a suite of national hydrological and groundwater models, and this dataset provided transient river flow projections across the 21st century. And headline results point towards decreasing low flows and worsening drought conditions, but there is uncertainty in the magnitude of change, and there is large uncertainty in low flow changes in particular across different hydrological models. And for those interested in the implications of transient projections for water resources planning, this recent paper on the bottom right here, led by colleagues at HR Wallingford, discusses the development and uptake of transient projections from a practitioner perspective. I think it's important to then bear in mind that the range of projected changes gets larger when cascading from rainfall changes to local impacts at a particular catchment. And this concept of the cascade of uncertainty is very common across a lot of climate impacts. One source of uncertainty is future climate forcing, and this is commonly assessed with different emission scenarios. For example, the figure in the middle shows the impact of emission scenarios on projected change in flood and drought risk, and it actually suggests that changes could be very similar until at least the 2040s or the 2050s, and it's only after around the 2050s that we see an escalated risk with the high emissions pathway. Another source of uncertainty stems from the response of atmospheric circulation to climate change, such as changes in jet stream dynamics or storm tracks, and these differ substantially between different climate models. And the figure on the right shows the global climate model that UKCP18 is based on, the HEDGEM3 model. It spans a much higher range in projected change for both floods and drought compared to other climate model ensembles. And we then quickly realized that even the most comprehensive study cannot fully analyze all of these sources of uncertainties. So we have to find ways to navigate this cascade of uncertainty. One way is to explore a much wider possibility space when thinking about the hydrological impacts of climate change. And since around 2010, we have seen the emergence of what's been called a scenario neutral approach. So this approach is not driven by GCMs directly, and they're often conducted independently from any climate change projections. And the example shown on this slide is a simulated change in flood peaks from a wide range of changes in precipitation variability. And a scenario neutral approach explores a wider possibility space and is useful to understanding the sensitivity of catchments to a wide range of climatic changes. And this approach has gained popularity in recent years, but the aim to assess catchment sensitivity is not new, and the scenario neutral approach clearly has roots in some of the earliest papers in the 1990s that I previously mentioned. Another way to navigate deep uncertainty is to focus specifically on those extreme high impact outcomes. So this was the aim of the H++ project a few years ago. And the concept of the storyline approach is motivated by similar aims. This is to explore extremes based on multiple hypotheses and framed around what if questions. So for example, we can reinterpret past events. So instead of treating the past as fixed, we can try and understand the consequences if past events turned out worse. So this figure shows one of my recent studies looking at what if the 2022 drought in East Anglia was followed by a winter with different atmospheric circulation patterns, such as the consequences of the combination of different climate drivers leading to worse cases. Another example focused on future projections on the right here. Future rainfall changes in the summer is uncertain because climate models don't agree on how the summertime jet stream will change. And we can then explore different plausible storylines by looking at the consequences if the jet stream shifts strongly northwards, which leads to widespread significant reduction in summer rainfall, or if the jet stream changes are less dramatic, which would lead to less drying and perhaps some wetting in the north. And I think the effects of climate variability on hydrological extremes is underexplored, and we could experience much more extreme events purely due to natural variability. And approaches like the Met Office unseen approach can be used to sample for these possibilities within large climate model simulations designed specifically to explore the effects of climate variability. So the example on the left uses the Met Office simulations to look at the potential for record winter rainfall, and it shows that high winter rainfall in the past could have been 30% higher, 30% wetter, purely from climate variability. And the same framework applied to hydrological droughts. I'm sure a similar story in the middle. And looking towards the future, this nature of variability is unpredictable, but it can be better characterized to identify and prepare for high impact events. And this is the aim of the Canary project, which will deliver the UK's first large ensemble climate model simulation designed specifically to explore the effects of climate variability on floods and droughts and the transition between them. And we hope this will be a useful source of model information in the coming years. So just a few reflections as a summary. We can see a clear climate change driven trend, especially for temperature, and some emerging trends in rainfall and flooding. There have been a lot of different approaches that researchers have used to understand the hydrological impacts of climate change, and I've discussed the changing nature of some of the major approaches over time. There are still several outstanding uncertainties, and in my view, these are some of the key ones. It is still uncertain how atmospheric circulation responds to climate change, and this remains the main source of uncertainty between different climate models. The effects of large climate variability and how they can lead to unprecedented floods or droughts are not yet fully explored. Scenario neutral analysis and a more targeted exploration of plausible worst-case storylines could help. And finally, hydrological model uncertainty remains an additional confounding factor. I've not really discussed this, but this also needs to be considered to make sure that our models are representing key processes accurately. So I'll stop there for now. Thank you for listening. Happy to take any questions.
Thank you very much, Wilson. So we're going to move over to a Q&A session now. So I will reshare my screen at this point. While I'm doing that, Peter, would you like to introduce yourself?
Yeah, so hi everyone, I'm Peter Rook, I'm CIWEM's Early Careers President, and I've been working alongside Hannah Burgess for the last year in preparing our presidential theme, attending various events. I represent a lot of the early careers professionals within CIWEM, so yeah, thank you Chris and Wilson, that was really interesting. And I think, Hannah, are we moving on to Q&A? We are. So we've got 3 questions so far, hopefully we'll get a few more. Chris, so I was wondering if you'd answer this one. To what extent is the CCC using behavioural science approaches to development of recommendations for policy and action? Do you feel like these sorts of approaches are relevant or appropriate? And if so, what frameworks and methods do you use? For example, the behaviour change wheel and the behaviour change intervention ontology. So yeah, probably quite a lot to unpack there.
And so I'm probably not the best person at the CCC to answer this question, but we do have a dedicated people, well, it's people and business, but they do quite a lot on behavioural change, particularly on the mitigation side. So yes, it is quite an important factor. It's also why we're looking to do the citizen panel to understand what those potential changes might mean for people themselves. And I think for adaptation, there's often an easy, it's kind of showing that vision of change that will then get people to accept those changes. I think it's a bit easier on adaptation because we actually can push a narrative around having better places to live. So I think, yes, to answer your question, yes, it's something we do consider, but I can't really tell you exactly what sort of frameworks we use because it's not my area of expertise, so apologies for that.
Thanks very much, Chris. And we've got another one directed towards you as well. So it says, do your recommendations include pretty much immediate measures the government or local authorities must take in quick time to be able to come into effect when they are needed? For example, halting the destruction of mature urban trees and planting them on a very large scale. Obviously, they'll not be very useful for heat dissipation for many years. At the moment, councils are still removing trees all over the place, which seem irreplaceable before urban heating reaches critical levels.
Yeah, I can't probably speak, well, I can speak to that example, I guess, but I think in terms of how agile we are with our advice, we are in this 5-yearly cycle. So, but we do have our periodic progress reports, which happen every 2 years. So we do have the opportunity then, and we're also producing reports quite regularly on various topics. So there is the opportunities to provide that advice if we feel there's something that's urgent, and the committee often will do that. We'll flag urgent things. Speaking to the point about urban trees, I totally agree that it's very short-sighted to be removing these trees right now because we know that the trees provide, and we have evidence to show that they provide a lot of benefits to urban environments, including reducing runoff, providing shading like you suggested, and reducing urban temperatures, but also biodiversity benefits and water quality benefits. So I think if you were to collate all those benefits that trees provide and how long that they take to grow to maturity, then I think we could easily recommend that but it's quite specific. Our advice is generally to government centrally. So it might not be as targeted as recommended recommendations like that. It'll probably be broader.
Cool. Thanks very much, Chris. And I'm not sure whether it's you or Wilson who's best placed to answer this one, but the next one is, how are GCM biases corrected for in dynamic downscaling? Is the coupled GCM hydro model calibrated to river flow?
I'll probably let Wilson answer that one.
Yeah, sure.
Thanks.
So the biases in global climate models, when they're dynamically downscaled, will still be the biases in the regional climate model. So the regional climate model takes the boundary conditions of GCMs to run a regional climate model, and there is still, the biases will be retained in that process. But when we try to input those into our hydrological models, we usually do a bias correction procedure for variables such as rainfall, temperature, evaporation, before we run those through our hydrological models. But you're correct that there will still be biases and uncertainties in different regional climate models, different global climate models. So that will still be retained within that dynamical downscaling process.
Cool.
It's probably important to flag though that when you dynamically downscale using the convective permitting model, so we've got the UKCP global model, the local model, the regional model, then the local model. The local model, because it has convective permitting, generally has smaller biases, certainly for temperature. And it's one of the benefits of that higher resolution model.
Okay, thanks. And I think someone else has a follow-up question for you, Wilson. So, as you say, atmospheric circulation and indices are big areas of uncertainty and projections. Do you believe that for people to properly understand climate scenarios, they need to have a deep understanding of circulation like the NAO, etc.? Do you believe that people need to have a full systems approach to understand scenarios properly? And is it even possible to properly have an understanding of future scenarios if there are so many different uncertain factors?
Yeah, thanks for the question. That's a very challenging one to answer, I think. But it is, you're correct that I think people need to have a deeper understanding of what atmospheric circulation means in the future, and we're very uncertain about how the response of atmospheric circulation to climate change might pan out. But yeah, I think in the end, I think quite a lot of these are kind of very uncertain, and it's not knowable really. It's epistemic uncertainty is due to our lack of knowledge. The best we can do is kind of characterize them better. And I've talked about ways to kind of focus on the more extreme high impact outcomes and try and characterize the climatic drivers of those outcomes better, and to understand what kind of climate drivers leads to unprecedented floods or droughts. And I think that's the only way we can be better prepared for when future extreme events turn up.
Cool. Thanks, Wilson. And I'm not sure which of you is best placed to answer this one, but we have, what are the considerations concerning climate change needing to be made designing a wastewater treatment plant?
I can have a go at that. It's quite specific. It's I guess probably the big one is increased rainfall, because then you potentially, particularly if we start to tackle CSO overflows, you potentially have more water to treat at treatment plants. So higher flows in the stormwater network, certainly, and more variability as well. So there'll be longer periods of dry weather interspaced by really extreme summer precipitation. But I guess also temperatures may be a factor. I'm not an expert on the processes, wastewater treatment processes, but I'm sure temperature might also be a factor. And then like broader risks as well. So flooding because these sites tend to be in right next to rivers and low places. So they do have a risk of flooding. So designing to ensure that they don't flood from both surface water and fluvial flooding. So quite a lot of different considerations. And we do actually have a new risk that we've identified that specifically targets wastewater systems.
Cool. Thanks for that. And got a question here, and again, I'm not quite sure who it's directed to, but is there a reticence to convective mitigate for the perceived impacts? Sorry, I think second one, it says, is there a reticence by the public for the perceived downsides, e.g. flood adaptation highlighting flood occurrences?
I can have a go at that one. I guess I think a lot of the times it's actually getting to the construction phase. A lot of the time there's often quite a lot of reluctance in local areas for new flood defences. But we have good examples of where, particularly from the recent storms, where people have been quite resistant to flood defence schemes. They've had them built, and then the storms have occurred, and those flood defences have basically saved them from those storms. So those communities then retrospectively become very, very sort of pro those, and I think we need to kind of highlight some of those case studies around where we've installed flood defences and the benefits that they're having. But it's a tricky issue, and I know from my own work that I've worked on a number of schemes where people have been quite reluctant to actually have the schemes themselves, particularly if they're not directly affected by the flooding. So yeah, it is a tricky one.
Do you have any ideas, Chris, on how you might want to promote that kind of positive thinking and sort of promoting certain case studies?
Yeah, I mean, it's probably, we will be looking at in our reports certain case studies. So for our Well Adapted UK report, we might kind of highlight specific case studies like this, where adaptation has been put in place and then the benefits that has had. Because there's numerous examples now, particularly with the recent extremes we've had. But I guess on the conversely, we've also had a number of schemes, particularly I'm thinking of in Cumbria, that have been installed, and then a couple of years later, so I know like Carlisle 2012, they had a new flood defence. There's new flood defences in Keswick and Cockermouth, and all those flood defences were overwhelmed in the 2015 floods. So it's kind of, I think, using the right case studies to kind of promote those, but also with the government saying, look, sometimes we need to think differently about how we're designing these schemes, particularly how we, as Wilson was talking about, how we deal with the uncertainty, because I feel in the hydrology space, we're not considering that full range of uncertainty, which we need to do in order to ensure adaptation is robust to a future climate that's uncertain.
Yeah, I mean, I know certainly for some of my flood investigation work, sometimes people expect you to come up with an exact number, and they don't really always appreciate that uncertainty. I don't see any other open questions. Oh, wait, another one. It's for you, Chris. So, quick question. In your presentation, you said that the well-adapted UK report is comprised of two parts. Part one of which is the effective risk management and action. And what was the second part?
So I'm not sure quite. So the Well Adapted UK report is setting out that vision of what a well adapted UK looks like and the actions required. The other part is the technical report, which is identifying the risks that the UK faces. So hopefully that clears that up.
Yep. Thanks, Chris. And a question for you, Wilson. What has been the most effective model approach for yourself?
Yeah, I don't think there is the most or the best model approach. I think each one of the approaches I've talked about have their own advantages and disadvantages, and but I think it's just an entire suite of approaches we can use, and it's kind of this suite of approaches we can use within a toolkit of understanding climate impacts, and we need to make use of them, make use of these multiple approaches better in order to inform our climate adaptation measures.
Brilliant. Well, I think that's all the questions I can see. So thank you very much for that. And Hannah or Duncan, I don't know if you wanted to close this out.
Yes, thank you. So we'll just wrap up by talking about the event next week and some follow-on events. But before I do that, I just wanted to give a big thank you to both of our speakers, to Chris and Wilson. Thank you very much on behalf of CIWEM and the BHS. So next Wednesday, you can tune in to watch our second webinar on flooding. The speakers include speakers from the Environment Agency, Newcastle University, and Bournemouth, Christchurch and Poole Council. I've created a QR code there, so if you're keen to register and you haven't registered yet, you can use that QR code and it will take you directly to the CIWEM website where you can sign up for next week's webinar. In terms of further events coming up on a CIWEM perspective, so obviously the webinars 3 and 4 of this series, and then into March, the CIWEM presidential team are running an event with the Local Government Association for Directors of environment planning and transportation on placemaking on the 6th of March. The day after that, both Peter and I will be with the CIWEM Rivers and Coastal Group in London for their technical conference. You can find more information on that on the CIWEM website. Into April, we are running CIWEM's presidential conference. Of course, it will be in the West Midlands, slightly biased there with my links to the local branch. And we're doing that on the ripple effect and looking at pragmatic examples of climate change adaptation from local organisations to the East and the West Midlands. So that's in Coventry, and that will be live to book from next week. And then I'd also just like to give a plug for the National Flood and Coast Conference and the early bird tickets that are now available for that conference in June. Over to you, Duncan.
Yep, very briefly, because I'm about to be thrown out of the meeting room that I'm occupying. Just a few events coming up. We don't have many dates set, but keep an eye on the BHS website. And also be aware that there are regional meetings as well. We're trying to revive the BHS regions and get together in person. Our next big conference, though, isn't until September next year. That's it from me.
Okay, thank you very much, Duncan. And thank you to everybody for joining. And we hope to see you again next week.